Hi, welcome back. So we're in chapter 3, you must know, on the outline of equation, function, and system. Now, before we move into a complete example, perhaps can clarify both mathematical and also graphical intuition, I would like to show you different number of equations and how the line would look like. The first one, we call it a constant function, where we can see here the value of y is always going to be 2. So x is not going to take any value because it's already determined to be 0. That's why we call it as a constant function. The other one, we call it a linear function, which we have seen so far. In this case, for example, I start from the origin here, and this is a line where every point in this line could be a solution for the function f of x is equal to x. The other one, we call it the absolute value function, which is basically says y is equal to the absolute value of x. That's why we can't see the region when x gonna get any value of negative. It will be absolute value. That's why this line is mirrored on the positive side of y. Also, we have another one we call the quadratic function. We have seen this example when the function get to the power of 2, or maybe a cubic function power of 3. We get the square root function, as you could see in this line is taking, for example, the square root of 4 get be 2, or 16 get be 4, something like that. And then we have also the cubic root square, and then we have the reciprocal function, which is actually a rational one, 1 over x, and you will get the value of y. Or you get the something called the reciprocal squared function, which is basically is going to take any value just like this by square it, then you will get no negative values of y is possible. You get the log function as well, the circle function, you get the sine and the cosine function. The idea is in here to understand is we are trying actually to create this by graphical perspective like we are seeing right now, or from mathematical induction. Now, I'm going to start with a comprehensive example, and we build up the idea based on that. It says that a ticket has been sold with a certain price. Actual system, I mean, in mapping a ticket to a price or price to ticket, doesn't matter how you see it, all right? If you set the price on 30, 50 ticket for sure to be sold. So in this case, what we're saying here, total value of money that I made. Now, if I substitute the values, I can get 1500. Now, from a graphical perspective, I can tell you that the money, the area of this box. Now, a new piece of information, it says if I drop this by 1, I can get the t to increase by 5. Now, if I want now to translate the relation between actually ticket and price, given a new information, total number of ticket, 5 every step minus from the price. Another way to write this from the perspective of a price as well, every 5 step on a ticket, reduce the price by 1. This is my intercept here. I am at the point of 30. Reduce the 30 will become till 0. I mean, charge nothing at all. 5 ticket I earn extra. It means the total number of ticket I could sell if I charge no money at all, it will be 150. Now, if I want to integrate the idea that we have just learned about the total number here is going to be 150, or from here also is 150. It's the same actually. Basically, I will end up with this triangle looks like this. Now, the information is telling me here, if I have 30, I know that I'm going to sell 50 for sure. Reduce the 30 by 1 step. It means in this case, S is equal to 1. The total amount of money, we know our equation that M is equal to this price, right? Multiplied by, it will be the initial value of 50 here, plus this area here. So what is this area here? This is the new value of t, and we have extracted this already here. We know it. But instead of this p, I'm going to replace this with s, so it will be unified with the same term. So 5s. Let's substitute the value of s by 1. Substitute the value. This is 50. This is value plus 5 multiplied by 1. 29 price multiplied by 55 ticket. This is the new area of my money. Okay, how about S is equal to 2? And that will be 1680, and so on and so forth. So you can do that, exhausting all the number of a step. What is the maximum number S could be? It's 30, because it means I have exhausted all the number. It means it becomes 0. The price becomes 0, in other words. So I would like to generalize the formula to come up with a function, if you will. Money is equal my 30 minus NES multiplied by my initial value of 50 that I know plus 5S. Now, if we make some algebraic arrangement, we know this is a power of 2, so we know it's a parabola. Now, how to graph this? This is the total money I am making, and this is the number of steps I am taking, right? I will be somewhere here at 1500. Anyway, I will make it, which is here actually. You can see it. By dropping one step, this 15 becomes 1595. And then if I drop 2 steps, it becomes 1620, and I will go up somewhere here. It will reach to the maximum amount of earn I can make on this 1500 by dropping this much number of steps. I take one step farther. From here, I will start losing actually real money. So the parabola or this function should look like this. I can make 2000 if I drop 10 steps. It means 30 minus 10. It means if I set my price to 20, how many tickets, of course, I have sold. So it is not difficult to find out. We know that the total number of tickets, if I exhaust all the 30, I will be only 150. But how many steps? We said 10. So if I follow the price now, it's 20 since I dropped 10 steps. And then I got to sell, in this case, 50 tickets extra. Now let's translate all of this. This is my actual total amount of money that I can earn if I just only sit on 30, the intercept, which is 1500. This is the maxima, which represent this point here at price of a 20, selling 100 ticket. And this is the point where if I just reduce all the price to 0, I would be able to sell the 150, which is this point here. So this side of the parabola is just equal to this side, and this side of the parabola is equal to this side in here. I hope this comprehensive presentation, how we actually were able to create this quadratic equation, translation from real world problem into a real math by graph and by numerical presentation. Next, we will be looking into the subject of trigonometry. I will see you then.